Hello everyone, this is our session 3 on matrices. Okay, so we had completed elementary row transformations, column transformations. Okay, and now we were on how to find the inverse of a matrix, a square matrix. So there were two methods. The first one was by elementary row and column transformations. Now we are starting with the second method, and that is called as the adjoint method. Okay, so let us begin with the adjoint method. It's a simpler method compared to the tedious task that we have in row and column transformations. So first, let us just remember what is an inverse. So A inverse is equal to I. Okay, that means if we multiply the inverse with the matrix itself, then we get an identity matrix. So that is how inverse looks like. And how do we find the inverse now? So the first one was elementary row and column transformations. The second method is called as the adjoint method. Okay, so let us begin with what is the adjoint method. Okay, for that we require to know few terms. So let us say that this is a matrix 1, minus 2, 3, 4, 5, and minus 6, 7, minus 8, and 9. Okay, so this is your square matrix. How do we find the determinant of this matrix? Remember, why do we need the determinant? To check whether the inverse of this matrix is possible. If the determinant is a non-singular matrix, then the inverse is possible. Okay, so let us find the value of the determinant. So 1 multiplied by 45 minus 48. Okay, minus of minus is plus 2 multiplied by 36 minus 42. Okay, and minus 3 plus 3 multiplied by 32 minus okay, so we have determinant of A is equal to 45 minus 48 minus 3, okay, plus 2 multiplied by bracket 36 plus 42, that is 38 and 78, okay, minus 3 multiplied by, because I'm taking the minus sign outside, 30, 65, 66, 67. Okay, so the answer here will be minus 3 plus minus okay, so the answer will be 153 minus 201, okay, which is equal to 8, 48, minus 48. So the determinant value of this is minus 48. It is not equal to 0, and therefore the inverse exists. Okay. Now, what do we require for finding it using the adjoint method? So I'll just write the matrix again. We have 1, minus 2, 3, 4, 5, and minus 6, and 7, minus 8, and 9. Okay. We require to know something called as cofactors and minors. Okay, now first, what is minors? So every element inside the matrix A can be represented as Aij, or we can say that it is a matrix of the order m into m, 3 into 3, and the elements can be represented as generally as Aij. Now what is Aij in the matrix given above? Let us say that we want to find A11. So what is A11? It is 1. A12, it is minus 2. A13, it is 3. Okay, similarly, we have the other elements. Okay, this is the elements. Now, what do we understand by minors? To find minor of any element, that means each element in the matrix has a minor. So how do we find the minor of every element? Let us begin with finding the minor of the first element A11. Okay, so you have to hide the row in which it lies and the column in which it lies. Okay, so how do we do that? I'm going to hide. Okay, I'm going to hide the row in which it lies, sorry, the column in which it lies and the row in which it lies. Okay, and then what do you have to do? You have to find the determinant value of this. Okay, you have to find the determinant value of this. So minor is represented by, okay, M11. Okay, how will I find M11? I said hide the row and column in which that element lies. Okay, minor of 1 will be 45. Okay, minus 6 8 is 48, that is minus into minus is plus. So answer is minus 3. This is minor of this element. Okay, similarly we can find the minor of, let us say, A12. So what do you have to do to find the minor of A12? We have to, A12 is which element? It is this element and this. Okay, let me tell you which element it is. So A12 is this element over here. Okay, so what do? We are going to we will find the minor of A12 now. Okay, so let us hide the row and column in which it lies. Okay, it lies in the first row and it lies in the second column also. So we've hidden those two. Okay, and then we will find the determinant value of the remaining. So M12, M12 is equal to 36 minus of minus, that is 42. Okay, so 36 plus 42, that is plus 78. Minor of this element is plus 78. Similarly, we can do it with any other element that you want to find. What do we have to do? We have to hide the row and column in which it lies and find the determinant value of the remaining elements. Okay. After we do that, then we find cofactor of each of the elements. Now, what do we understand by finding the cofactor? Okay, so there is a symbol for cofactor. It is Aij. Okay, and it is found out as minus 1 raised to I plus j multiplied by mij. Okay, what does this mean? Cofactor is equal to minus 1 raised to, okay, I plus j, that is addition of the row and columns, multiplied by its minor. Similarly, so let us say that I want to find out the cofactor of the first element, that is A11. Okay, so the cofactor will be denoted by A11, capital A11 is equal to, okay, bracket minus 1 raised to 1 plus 1, that is 2, multiplied by, what is the minor of A11? It is minus 3. So I'll put it here. Okay, minus 1 raised to 2 is plus 1. Okay, and multiplied by minus 3, answer is minus 3. So what is the cofactor? Minus 3. Okay, similarly, let's say I want to find the cofactor of A12. Okay, so it will be minus 1 raised to 1 plus 2 multiplied by M12. Okay, so which will be equal to minus 1 raised to 3 is minus 1 multiplied by, what is M12? It is 78. So what is the cofactor of the second element? It is minus 78. Okay, in this similar manner, we can find all the cofactors. That means each element in the matrix has a minor and each element in the matrix has a cofactor. Okay, now how this helps us to find the inverse. So when we find the cofactors, okay, so we'll get a matrix of cofactors. So we can write this as matrix of cofactors of the matrix A, okay, matrix of cofactors is equal to, okay, and then bracket, and then capital A11, A12, A13, A13, A21, A22, and A23, okay. Then last one, A31, A32, and A33. Okay. This is your matrix of cofactors. Now, if this is your matrix of cofactors, then what is adjoint? Okay. What is adjoint? So adjoint of A is denoted by ADJ capital A is equal to transpose of matrix of cofactors. Okay. What is adjoint of A equal to? Transpose of matrix of cofactors. Transpose is inverting the rows and the columns. That means where there is a the first row becomes the first column and the first column becomes the first row. Right? So how do we find adjoint of A? It is the transpose of matrix of cofactors. Okay. Then the last step is to find the adjoint. So the last step is given as, sorry, to find the inverse, not adjoint. We already found the adjoint. Then we say that inverse of A, okay, is equal to, okay, 1 upon determinant of A multiplied by adjoint of A. Okay. What does it mean? Inverse of A, that is A inverse, is equal to 1 upon determinant of A multiplied by adjoint of A. So what is the first step in the adjoint method? First is to check whether it is singular matrix. Then we know that its inverse exists. Okay. Second is to find the minors of each of the elements. Third is to find the cofactors. Okay. Fourth is to make a matrix of the cofactors. Okay, this one over here. Okay, and the fifth step is to transpose that matrix. That is, make rows as columns and columns as rows. Once all these steps are done, we use the final formula, inverse of A. Okay, inverse of A is equal to 1 upon determinant of A multiplied by adjoint of A. 1 upon determinant of A, determinant we've already found in the first step, right? And multiplied with adjoint of A. Now here this thing you have to remember that determinant of A has to be non-singular. If it is equal to 0, then what will happen to A inverse, or what will happen to this formula? You will have 1 upon 0, which is infinity and cannot be divided by the adjoint of A. Okay, so you cannot find A inverse then. That means A inverse does not exist, right? That is why, remember, non-singular matrix is important. Then only inverse exists. So this goes to the basics of how an inverse exists. Okay. This is your method, adjoint method. Let us take a simple example to first understand the method. Then we can go for a 3 by 3 matrix. We'll start with a 2 by 2 matrix first. So example, first one. Let us say we are taking a matrix A equal to 1, 2, 3, and 4. Simple. Okay. So we'll try and do a table format so that there's no confusion as to what matrix is to be made. Element, okay, then it's minor, okay, and then it's cofactor. Now, elements are A11, A12, A21, and A22. Correct? First, second, third, and fourth. Now, A11 is your first element. A12 first row, second column 2, A21 second row, first column 3, and A22 second row, second column, that is 4. Okay, then how do we find the minor? I had said hide the row and column in which that element lies. So A11 lies in the first row, first column. Let us hide that. Okay, we've hidden that. So what is the minor over here now? See, now what is a 2 by 2 matrix, no, will not let you, will not um, have a complicated determinant to find. You directly can see the minor, it is 4. But if you have a 3 by 3 matrix, then when you hide the row and column, you will have to find the determinant value. Okay. So here the minor M11, okay, M11 is equal to 4. Okay. Then M12. How will we find M12? M12 means this one and this one, right? Sorry, the row in which it lies and the column in which it lies. So it lies in the second column and the first row. We've hidden that, and so we are getting the answer as 3. Okay, then next M21. So again, let us hide the row in which it lies. So this, it lies in the second row, and the column in which it lies. So the answer is 2. Okay, so we'll write over here 2. Okay, and then we have M22. So again, what we'll do is we'll hide the row in which it lies. So it lies in the second row, correct, and it lies in the second column. So what is the answer here? It is 1. Okay. These are the minors. Now, how do we find the cofactor? So cofactor is equal to A11 is equal to minus 1 raised to I plus j, that is 2, multiplied by its minor, so 4. Okay. Answer is 4. A12, okay, is equal to minus 1 raised to 2 plus 1, that is 3, multiplied by 3, answer is minus 3. A21 is equal to minus 1 raised to 3 multiplied by its cofactor, that is 2 minus 2. And A22 is equal to 1, minus 1 raised to 4 multiplied by 1. So answer is 1. We found all the cofactors. Let us make matrix of cofactors. So matrix of cofactors is equal to, let us put all the elements, A11, 4, 1, 2, minus 3. So 4 minus 3, okay, and 2, 1 minus 2 and 2, 2 is 1. So minus 2 and 1. This is your matrix of cofactors. Next step is to make its transpose. Okay, so we write it, adjoint of A is equal to transpose of the above matrix. So transpose of the cofactors. I'll just mention it here for the first time. So transpose of Aij, okay, that is this matrix on top. Okay, so that will be equal to, make the row as the column, correct? This is your adjoint of A. Last step is to find the inverse. Okay, so A inverse is equal to 1 upon determinant of A, okay, multiplied by adjoint of A. Now, one step we skipped, or we can say we forgot, is to find the determinant and check whether the inverse exists, right? So let us see the answer for the determinant of A. So determinant of A is equal to, determinant of A is equal to, how do we do this? 4 minus 6, which is equal to minus 2. So yes, the inverse does exist. And how do we write it over here now? Inverse 1 upon minus 2 into what is the adjoint of A? The matrix that we've got by taking the transpose of cofactors. 4 minus 2 minus 3 and minus 1. Okay. Sorry, minus 3 and 1, not minus 1. Yes. So that is your adjoint of A multiplied by the determinant. And this is how you find the A inverse. Okay. So if you follow the procedure, then it is very simple to find it using this method. But if you do not, then it becomes a little difficult, because then if you skip a particular step, you could make a sign mistake. Okay, so let me go back and just revise through the steps that you require to find inverse using a adjoint method. Okay, so let us begin from the matrix that we have here. Yes, this matrix. Okay, a 3 by 3 matrix. So any matrix you can take while doing so. So what does it say? You have to first find the determinant value, check whether the inverse exists. If it exists, then we start with finding the minus of each of the element inside the matrix. Okay, once we find the minus, then we find the cofactors. Okay, cofactors, there is a formula, minus 1 raised to I plus j multiplied by its minor. So every element will have a minor and then it will have a cofactor. Then what we'll do is we will make a matrix of cofactors. Okay, after we make the matrix of cofactors, how do you find the adjoint of that matrix? We will transpose this matrix of cofactors. So adjoint of A is equal to transpose of matrix of cofactors. Then we say inverse of A. What is inverse of A then? 1 upon determinant of A multiplied by adjoint of A. So this is a little tedious step over here, that is finding the adjoint. Okay, and then determinant we've already found out to check whether inverse exists. You just have to divide it by the determinant. Okay, let us begin with the exercise, or rather there is one example that we should study because this is a general form that every matrix will follow. So let us take that example. So we have if A is equal to 1, 2, 3, and 4, same matrix we are taking. Okay, if A is equal to this, verify that what do we have to verify? A into adjoint of A multiplied by adjoint of A is equal to adjoint of A multiplied by A is equal to determinant of A multiplied by identity matrix. We have to prove this. Okay, so let us begin. We already know how to find the adjoint, so I'll just quickly do that for you. So A is equal to 1, 2, 3, and 4. Okay, its determinant value let us find and keep. We will require it. So 4 minus 6, that is minus 2. Okay, now how do we find adjoint? A11, A12, A21, and A22, sorry, are the elements of your matrix 1, 2, 3, and 4. Okay, then we find the minors. So we have M11, M12, M21, and M22. Okay, so M11 is equal to 4, M12 is equal to 3, M21 is equal to 2, and M22 is equal to 1. Okay, then again we have the cofactors. So A11 is equal to minus 1 multiplied by the minor, so which is equal to 4, A12 which is equal to minus 1 raised to 3 into 3, that is minus 3, A21 is equal to minus 1 raised to 3 into 2, that is minus 2, and A22 is equal to 1. Okay, so matrix of cofactors will be matrix of cofactors 4 minus 3 minus 2 and 1. 4 minus 3 minus 2 and 1. Okay, adjoint of A is equal to 4 minus 3 minus 2 and 1. We've taken the transpose of the above matrix. Now, the first thing that is to be verified, A into adjoint of A. So A multiplied by adjoint of A is equal to, what is our A matrix? 1, 2, 3, and 4. What is our adjoint matrix? 4 minus 2 minus 3 and 1. Let us find the value. So how do we do this? Multiply row into column. First row of the first matrix and first column of the second matrix. 4 plus into minus minus, 6, 4 minus 6, minus 2, minus 2, plus 2, 0, okay, 12, minus 12, 0, 3 plus, 3 into minus 2 is minus 6, plus 4 is minus 2. Okay, this is A into adjoint of A. Okay, let us do the next one, adjoint of A, okay, multiplied by A, which is equal to, what is our adjoint? It is 4 minus 2 minus 3 and 1, multiplied it with A. So 1, 2, 3 and 4. Let us multiply and check the answer over here. 4 minus 6 minus 2. Okay, again 8 minus 8, 0. Minus 3 plus 3, 0. Minus 6 plus 4, minus 2. Okay, this is adjoint of A into A. The last one is determinant of A multiplied by identity matrix. What is determinant of A? Minus 2. And what is our identity matrix? Okay, so what is the answer? Minus 2, 0, 0 and minus 2. Okay, why did we do this verification? Any square non-singular matrix satisfies this equation. Okay, so we have to remember this for any square non-singular matrix satisfies this equation. What is this equation? A into adjoint of A is equal to adjoint of A into A is equal to AI. Determinant of A multiplied by I. Okay, this is true for any non-singular square matrix. Non-singular because its inverse should exist. Okay, if its inverse exists, then only this will be true. All right, let us let us begin with an exercise based on cofactors and adjoint method. So the first sum says that find the cofactors of the elements of the following matrices. Okay, the first matrix is a 2 by 2 matrix. I'm skipping it. We've already done it twice now. So we'll do the 3 by 3 matrix. They say that find the cofactors. So let us begin. The matrix is let us call it A. So A is equal to 1 minus 1 2. Okay. Minus 2 3 and 5. Okay, and minus 2 0 and minus 1. Let me check. Minus 2 0 and minus 1. Okay, this is your matrix. What is our first step to find cofactors? We require the elements, right? So we'll take an elements table. We require minors of the same, and then we require their cofactors. Okay, so only cofactors are to be found. It's simple. Elements A11, A12, A13, A21, A22, A23. Okay, let us do these many first. So elements we can directly write 1, minus 1, 2, minus 2, 3, 5. Okay, and we have A31, A32, and A33. So what is A32? A31 is minus 2, 0, and this is minus 1. Okay, let us write the minors of the same. So M11 is equal to M11. What do we have to do? Hide the row and column in which it lies. So when I hide it, I get a determinant. Let us find the value of that determinant. Minus 3 minus 0. So minus 3. Okay. M12 is equal to minus 1 lies in the second column, first row. So hide that. We have 2 minus of minus, so plus 2 plus 10, that is 12. Okay. Then M13 is equal to first row, third column. So minus 2 into 0 is 0, minus of minus plus 2 3 is 6. Okay. M21 is equal to M21 is this element. Okay, so what do? Hide the row and the column. in which it lies. Second row, first column. Okay, so when we hide the second row and the first column, we are left with -1 multiplied by -1, that is 1, minus 0, that is 1. M22, okay, that is this element over here. M22, that is 3. So how do we find the minor of this element? Second row and second column, hide it. So we have 1 into -1, -1, minus of minus plus 4. So -1 plus 4 is plus 3, M22. Then M23 is equal to last row, last column, second row. So we're left with 0 minus of minus 0 minus 3, that is, 0 minus 2, that is minus 2. Okay, and then the remaining 3. So M23, 31 is equal to M31 is equal to, that is third row, first column. So third row, first column, when you hide them, you get -5 minus 6, that is -11. Okay, then we have M32, that is third row, second column. Okay, so we have 5 minus 4. Okay, 5 minus of minus 4, that is plus 4. So 5 plus 4 is 9. Okay, then M33 is equal to, that is the last number that is remaining, -1. So last row and last column. So when we hide them, we get 3 minus 2, that is 1. Okay, so these are our minors. How do we find the cofactors now? Okay, now in a 3 by 3 matrix, what will be the cofactor sign? We can't be sitting and multiplying it all the time. So what we can do is, it's very easy to remember the sign. Directly just put the sign and the number. So A11, A12, A13. Okay. Okay, A11, A12, A13, A21, A22, and A23. Okay. Now, what is A11? 1 means addition is a even number. That means -1 raised to an even number will be plus. So the sign of the minor will not change. It will be -3 only. A12, addition is a odd number. So sign will change. So if M12 is positive, it will become negative, -12. Okay, 13. Again, it is a even number, addition. So that means sign will not change. Okay, it will remain 6 only. Then A21. The addition of 2 and 1 is 3. So it is a odd number. That means sign will change. So A21, M21, opposite of that will be -1. A22, again an even addition. So -1 raised to 4 again will be positive. So sign will not change of the minor. What is the minor? M22, it will remain 3. Okay, A23. Addition is an odd number. So -1 raised to an odd number, answer is negative, right? So whatever will be the sign, we will invert it. So -2 will become +2. Okay, the last one, A31, A32, and A33. Just check the addition. If it is even, answer remains as the minor. If it is odd, then the answer changes the sign of the minor. So A31 is raised to 4. That means sign remains the same. A32 is odd number, so sign changes. A33, again even, so sign does not change, right? So we don't have to sit and multiply it all the time. We can just directly write the answers of the cofactors. Okay, now let us put the matrix of cofactors over here on the same page, and then we can put, or rather we'll write the matrix of cofactors separately, so that what will be matrix of cofactors? Just arrange all the elements in a matrix, all the cofactors that you have found out. So first row will be -3, -12, and 6. Okay, then second row will be -1, 3, and 2. Okay, and the last one will be -11, -9, and 1. This is your matrix of cofactors. Okay, this is the first question only of the exercise. They've just asked you to find cofactors. You can go ahead and check for the adjoint as well as the inverse. So adjoint, what do we have to do? You have to take a transpose of this matrix, and for the inverse, you have to divide the transpose with the determinant of the matrix. Okay. In the next session, we will do the remaining sums of this exercise, in which you have to find the inverse as well. Okay. If you have any doubts in how to find the adjoint, please let me know. I'll repeat it for you. Thank you very much.